This week we're going to be talking about water. You guys know H2O is the chemical formula for that. And to give you a little bit of a background, the chemical structure is going to be oxygen, hydrogen, hydrogen, right? And now, key thing here is oxygen can form a maximum of 2 bonds. Hydrogens have only 1 bond, right? So this molecule of water right here, oxygen has its 2 bonds, all's good, and each hydrogen also has its own bond. All is well, right? Perfect. So you have the chemical formula down and the chemical structure. Now, important thing to talk about here is, especially since we're dealing with the body, how much of the body is made or composed of water. And we're going to say the average number is 60. Okay, and this does vary from class to class. So if we look at this range here, we're just going to say 45 to about 70. And again, there's a number of factors that can affect this, and your textbook will vary with the average, but we're going to set it again right around 60. Okay, so let me go ahead and get this out of the way for you guys, and we can break down the groups of composition a little bit further. Sorry about that. All right, so if we break the groups down a little bit further, you guys, I'm sure, have heard of intracellular and extracellular. Let me go ahead and set this pen up for you guys one more time. Okay, so you have intracellular and extracellular. And I'm only writing the first 2 letters of each word for a reason, okay? In, you guys know, is inside the cell. Extracellular, think of maybe exit, exiting, leaving the cell, outside of the cell. So intracellular is set at roughly about 66%. And again, that's in for inside the cells. Extracellular, we're going to look at a little bit further, okay? So of course we know 100 minus 66, the remaining percent must be 34, correct. And again, this is fluid outside the cell. However, this one has 3 different subgroups. Okay, so you have your interstitial, you have your intravascular, and the last group that you have is your transcellular. Let me try to write this here. Transcellular. Okay, so again, 34% composed of 3 groups, right? Those 3 groups we said were interstitial, which is in between the cells, right? So if you take an international flight, you're flying in between nations, interstitial. The second one was intravascular. So again, vascular, we're talking about things like blood, plasma, and the third one was transcellular, meaning within body cavities, things of that nature. So just remember, inside the cell, majority at 66%, outside the cell 34%, with 3 subgroups, interstitial, intravascular, and transcellular. Now, let's get that out of the way for you. If we move on, you guys know that water moves around via osmosis, so remember that term, osmosis. And there are 2 factors that generally affect this here, especially within the body, okay? We're going to talk about first pressure. Okay, so just let me write that down for you here, pressure. Now let's say you have some sort of vasculature here, okay? And let's say we have, just for conceptual purposes, water right here on this side, and we also have water far greater amount on this side. Okay, so if you look at the left here, we have not spread across the entire diameter. There's ample room inside this vessel, no pressure buildup. Okay, the force to push water out is minimal. Here, space is very tight. We're very competitive. It's very clustered. The pressure against this vasculature here for this water to move out is going to be far, far greater than on the left, right? So this would have a much higher pressure. And that's the first one that we talk about, moving water. And again, in some other classes, for example, anatomy and phys, you may have heard of the terms and the different values for this. You guys know this pressure can be like we applied it here, pushing out, but you also have pressure that can be applied inwards, pushing in, right? So just make sure you keep that in mind, that it can go both ways. So that was the first one. The second one that we're going to talk about is electrolytes. So let's say again here we have this time a pink vasculature, and we're going to say that sodium is greater concentration on the outside than maybe inside. It's kind of a small one here, right? So sodium's far greater on the outside. In general, the rule of thumb, salt pulls water. So you guys see here, any water that would be inside this vasculature at this point in time would be pulled out towards the greater sodium concentration. Why is this important? This, for example, when you guys get to the kidneys, the renal system and your urine and all that, this is very, very important when it comes to things like blood volume. Okay, so if somebody has a high blood pressure, you guys know they have a high blood volume. Okay, and I'm sure somebody in your family or somebody close to you, you guys have heard maybe with high blood pressure, they need to have a low sodium diet, right? Depending on how severe, you may want to avoid it totally. So sodium, why would this be important here? Well, like we said here, sodium is going to pull the water. All this water will increase the blood volume on the outside here of our vessel, vasculature, which will increase the blood pressure even further, right? And again, remember this too can be both ways. If we had a greater sodium concentration inside the cell as opposed to out, the water would flow in. And here we had greater outside as opposed to inside, so the water flowed out. Okay, just want to go through some general functions with you guys of water real quick, and then we'll end this for today. All right, so, and again, these are just some general functions. So the first one, and I'm just going to list these and discuss them with you guys a little bit here. Let me just get a font. All right, so the first one that I'm going to list here is going to be solvent, right? You guys know the solvent dissolves the solute. So if the solute would be salt that I put in water, it would be dissolved and become salt water, right? And again, water is a solvent for many, many things, electrolytes, all those things. The second thing is water is a huge transport medium, right? And I say this because water transports tons of things. How do things get transported around primarily in the body? Well, if you think of blood, blood is 90% water. What does blood do? Moves oxygen, waste, nutrients, all kinds of stuff, right? So water in this case would be a transport medium. You can also take into consideration your lymphatic fluid and your urine should you need to go any further. The third one that we're talking about is lubricant, right? Water is a lubricant. So if you think of synovial fluid in the knee joints, if you think of, even if your eyes, the fluid within the eyes or outside around the eyes to carry out the dirt to prevent anything from really building up in there, water is a lubricant, helps those interactions. And again, the synovial fluid, like we said, in the knee joint, preventing the bone-to-bone bumping and things of that sort. Of course, you also have water necessary for metabolism, right? Water helps break down things and so forth. Moving on, one of the next functions that we are going to talk about is body temperature. This is probably the first one that came to mind for a lot of you guys. You guys know the higher your body temperature is, the more water forms on the surface, right, to help cool you off. And again, If you do the opposite, let's say you're taken from a hot environment, put into a cold, the less and less water you're going to give off in an attempt to keep your body heat as high as possible, right? And the last one that I'm going to talk to you guys about is the pH balance. And remember, we talked about this. Actually, let me just write so you guys have the list here, pH balance, right? We talked about this with the amino acids already and how they're groups at the ends. Remember the four main groups? How some of those could accept a hydrogen, how some of those could get rid of a hydrogen, and how they help regulate the acid-base situation here, right? So in general, water can be considered an acid or a base. You guys know that the hydrogen is always considered acidic. So if I have here hydrogen, and I have in here the OH, which would be a base group, right? You guys know this could accept the hydrogen and form water, right? Water, in turn, can again act as a acid or a base. If we break it apart, giving us OH and H, it acted as an acid in this case, and again as a base, right? We could take up another H and make other compounds here. So again, just take into mind that water is an acid and or base, and it can be a pH regulator, right? All right, guys, that's going to be it for today. Thank you very much, and I will see you soon.